Hello, everyone. Welcome to the latest session in our Siemon TechTalk series. My name is Christopher Homewood, Global Marketing Leader at Siemon, and I'm delighted to be joined today by my colleague Lee Funnell, our Technical Services Group Manager for Europe, Russia, and Central Asia. As network infrastructure has continued to evolve in recent years, there has been a recurring question around the long-term role of copper cabling and connectivity within the data center, LAN, and intelligent building environments. And each new technological innovation, everything from optical fiber to Wi-Fi 7 and Li-Fi, continues to be launched alongside the phrase, will this new technology mean the end of copper cabling? But the industry continues to see sales continue to rise for copper. So what is the reality? In today's session, Lee will explore this in more detail, reviewing the ongoing growth of copper-based networks, as well as the new technologies and future roadmap we all need to be aware of. As always, if you've got any questions during the session, please enter them into the panel provided on the right-hand side, and we will have a short Q&A discussion at the end to address them. Okay, Lee, over to you.
Thank you, Chris. That's a great introduction, and thank you so very much. And thank you for everybody taking time out of your day to join this session, which I hope you'll find insightful, thoughtful, and will hopefully lead to some really good questions and discussions at the end. So with no further ado, let's move forward. There we go. So today what I really want to focus on is what is the size of the copper cabling market, the impact of converged intelligent building designs and how that's affecting how we move forward, the ongoing growth of copper-based networks, the new technologies we're seeing, and what the future holds, and that's quite interesting. And then just really to get into some of my thoughts and a really good and open discussion with all of you guys. And if you want to put your questions into Chris through the text box, that would be absolutely superb. So according to some of the markets out there and Global Market Insights, they're currently predicting a 10% sort of annual growth, reaching a massive global spend of $35 billion by 2028. And we are really seeing an onward trend in the development of copper solutions for the enterprise and for the data center market. The real growth of fiber has really been born out of this new need for what we call hybrid working, people from working within the office, and more importantly, people now being able to work from home. So we've really seen a tremendous growth in the fiber to the home market being provided by the telco carriers. So everybody who has higher data bandwidth availability to support the businesses that they work for, both at a personal level and at a business level. And I really don't see that market reducing in size. And in fact, I only see the fiber to the home market really, really growing. And we have to remember one of the potential reasons for this is many of the home-based telco supplies, they're largely copper-based, installed in sort of like the mid-1970s. Many of those networks are really becoming to the end of their life. So these companies are really having to now start thinking about installing fiber cable, whether that's directly from the central office, directly to the home, or for what we call the last mile. But we are really seeing a tremendous growth in fiber cabling. But that real growth is predominantly within the external networks provided by the main telco carriers. The copper market is going to continue to see growth, and this is really in support of what we call the converged or the intelligent building space. The reason for this is many companies have lots of now green initiatives. They're thinking about how can we reduce power, and equally how can we enhance the user experience? How can we make our office environment more attractive to keep people coming to these very expensive real estate locations? And how can we also improve staff retention? And all of this really does fall within that sort of copper network basis. So to me, there's some management drivers that are really driving how the copper networks are growing. And there's typically three areas that I see. One is from the environmental side, where we're looking for greater efficiency, energy reduction, and how can we as a business promote ourselves to be more eco-friendly, to be more demonstrate our corporate social responsibilities to not only ourselves but also to our customers, and even clients and end users are really pushing for this sort of growth at the moment. From the owner of a building, it's going to be really about how do we get that integration, the technology working together. But it's not just that. They've got to think about how much they're going to be paying for these copper and fiber-based networks going into these buildings. And it's really about how flexible can they make these buildings work for them and for the future. And by the future, that means longevity. You know, how long can we leave these copper networks in place that are going to deliver what we need today? And I really think for that, the big driver on that is going to be the growth for category 6A data throughput up to 10 gigabit networks and anything under that level. We really are seeing that, you know, networks are becoming more focused and more data driven, you know, every day. And then we have that user experience, and the user experience is really sort of over I think three areas. One is security. How do I make my office and my environment safer for me and for my family? And that also goes into comfort and health. So there's lots of management tools now that are available to do people tracking, to be able to manage how many people are in an office at any one time. Many offices are still operating with some level of separation from their own staff. But the other part is about satisfaction. You know, how quickly can we make the building work for them in terms of lighting, in terms of cooling, in terms of heating, in terms of access to the network, things that people want to do. So all of these things are really going to be driving together. So if we look at this, it's really about, from that environmental side, yeah, making your building work better, making your building more aligned as a system. We constantly see lots of people talking about, I want to develop an integrated building. But the reality of it is they largely still take what I call a siloed approach, that many systems are very disparate from one from another, that they're not fully integrated, they don't fully work together. One great example of that, of having a building working fully together, is a fire alarm system. Why don't we tie our fire alarm system into our intelligent lighting system? Because we've got sensors and controls that literally will tell us where a fire is, and it will raise alarms and everything else. But we can actually use the lighting system to turn LED lighting panels green or red. So we can actually show a safer escape route out of a building by literally turning the ceiling into a fire escape route guidance system, rather than sending people towards an escape route that might be congested or might actually have a fire in itself. The other part is making that building more energy efficient. What can we do to reduce energy costs? And that is huge for any company. What can we do to reduce the cost? And it is about using sensors. It is about using active intelligent systems, communicating not only from HVAC systems and heating systems, but literally to how the whole building is being used as one, and how do we manage the movement of staff? How do we only heat the areas that we need to heat? How do we only cool the areas that need to be cooled? And that's a huge cost saving. And of course, so that moves into what we call being green. And many times I've said this before, there's two types of being green. There's green from the environmental point of view, but then there's also green in the pocket. How much cash can you actually save in your operational expenses back to the business? Focus on increasing staff retention. And that might seem strange, but one of the biggest complaints or concerns that I've seen out of many, many companies that I've worked with is it's very expensive to find staff at the moment. It's very expensive to train them and to bring them on, and it might take several months before they truly become really productive into that business and what that business needs them to do. So some of these things is really about trying to engage that staff retention. You know, what can we do to make the staff feel safer in buildings? Can we make it a great place to work? You know, with system access controls, infotainment, all of these solutions that we're only at the beginning edge of really understanding how we can make a building better for those individuals. And that really is important that we work with our systems integrators and work with our clients to understand what is their end dream for that building. How can we do it? We can obviously now look at things like comfort and health systems. We can look at traffic flow, air quality, etc. We can do these things today, but we've got to make them integrated, got to make them work together so that user has full control of their own environment, so they have a better working environment. And then you've got the owner. Well, in order to achieve these, previous goals, and having systems that work is really going to be down to the owner. And it's really about the careful selection of technology, thinking about flexibility and longevity. It costs a lot of money to put network cabling into a building, so we've got to make sure that we get the most out of it. And the reality is that copper is the mainstay for the enterprise building, because we've got to think about, I've got to design this building so whatever technology changes, how technology develops, how the user experience will migrate and move, how can I make it I don't have to recable that building. So one of the things that we talk about is a lot about zone cabling, making sure we're putting in an extra percentage of outlets so we can make the building do whatever it needs to do today, but also whatever it needs to do in the future without having more back at the CapEx sort of side. We've got to think about the operational cost. How can we make it more flexible? How can we make it support the growing needs of that business? And that really is, again, going back to that cabling infrastructure. Many buildings will be cabled, and then the client or the building owner might want to change the usage of that building. They might want to change meeting rooms. They might want to change office areas. They might want to change areas into working group locations. So the more that we can think about how we can flexibly deliver that, move lighting systems, still provide data to wherever the outlets are required in that communication, that space, is really, really important. And then the next thing is, how do we protect our investment? And the reality is the protection of investment is not going back and reinstalling because the original design wasn't perhaps where it should have been. So a lot of this is really working with system integrators, people like us, to truly understand not just where the company is today, but where does that company want to be in terms of 5 years and 10 years time. So a lot of consideration needs to really go in to thinking about the technology, the flexibility and longevity of a system. But when we think about future technologies and what should a building do and how should it work, I'm a great believer that the focus should not be on the actual technology that exists today. The focus really needs to be on what do you want that building to achieve, rather than the equipment that's available on the market today. And the reason why I say this is we are seeing technology change. It feels like almost on a daily basis. I might one day look at this type of technology and think that's really, really good. That will deliver exactly what I need it to deliver. But in the 6 months, 8 months, 2 years time of planning, that technology won't exist. It would have been upgraded, it would have changed, it would have migrated. So really what we're going to do is think about what do we want that building to do, and almost think about the technology almost at the end. We can have an understanding of what we want that building to do, but our focus shouldn't be on the technology just yet. The technology will follow closer to the handover an office space or a building, because everything we do today, there's going to be a better solution out there in a couple of months. So for me, our true focus needs to be really on what I call the small sensor-based control systems and the large data transfers that will go from point A to point B. The sensor controls that will go into the building management systems, the large data files that are going to go into your data centers. And if we want longevity in our data transfer, then we really need to think about the cabling plant we're going to use. And the reality is it's going to be category 6A. And I'm always going to shout for shielded solutions. And the reason for that is the enhanced security of the data that it travels. Shielded cables have got a lot of protection against unwanted electromagnetic interference, especially at high data rates. But it's not just that. If we think about it, we're all seeing that growing demand now for what we call PoE, Power over Ethernet enabled devices. And the reality is, it's the data cabling that supports that. And that's really going to drive how effective we can make that building and really drive some of those energy savings that we're going to see by delivering power directly to a PoE enabled device that's intelligent, that's connected. And that's going to have a massive reduction on the amount of additional electrical circuits that we're going to deliver into a building, you know, and the number of trades that we're going to have on site to deliver a project. The more that we can run over that data cable, the more flexibility we have, the more longevity we have, and the greater chances we have by using sensor-based technology to control those environments to make sure that they work effectively. So as I think about this and I think about technologies, really, what do we have? What's new? What's old? What could be portrayed by marketing as being a new technology? And sometimes some of these new technologies, they're not that new, they're quite old. But do they really offer what they say they can? And I take us back now to just the whole idea of trying to build a roadway. If we can build a roadway that's going to be able to support 10 gigabit Ethernet, we're building a roadway that's going to support a building for like 20, 25 years in advance. Yeah, we've got to think about the technology that's out there and perhaps some of our technology partners. Are they just trying to sell technology that exists today, but they know that there's better technology coming because they've obviously got sales targets to hit? The real focus should be on really where are we looking to be and what technology is going to be available when we need it. We don't want to take technology that truly exists today. So if we think about power over Ethernet, and I'm sure many of you have looked at this and many of you, are moving towards PoE-based solutions. Well, the interesting thing is that the PoE solution market is just staggeringly growing, an almost 7% year-on-year growth, from 2022 to 2027. And if we think about it, the reality is the amount of devices that we can now power over Ethernet is staggering. Yeah, we got traditional stuff that's been out there for a while. We've got IP-enabled CCTV, we've got wireless access points, we've got IPTV, public address systems, wall clocks, free space optic systems, industrial control systems that just doesn't affect us, will also affect into the industrial environment. But the real sort of things that I'm thinking of is not just like the intelligent lighting systems. It's things like AV systems, computers, laptops. All of those technologies are now really being developed and delivered, so they will also now run on PoE. So some of these larger power-hungry devices are actually becoming more compliant or more adjusted to work with power over Ethernet. I mean, if you think about it, if everyone's got a laptop, you might have 220 volts, 230 volts coming in from your socket on the wall, your electrical socket. But the first thing that it meets is a power converter that reduces it from 230 volts down to 12 volts. Well, if we're going to drop down to 12 volts, then we can easily run that on power over Ethernet. So there's a lot of change that's happening in the market, and it's great to see. Lots of people talk about wireless access systems, and there is a huge growth in wireless access systems. And I'm sure that many of you are much younger than I am, but I do remember when wireless access systems first came onto the market, it was incredible. And you almost could take whatever the data rate was of the box, and it would pretty much deliver pretty close, 90% of what it said on the box. But that's not the case now. The reality is we've got so many wireless networks in such a small location within an office environment, we're having to install more and more very expensive wireless LAN systems to be able to support our customers. Now, what we're seeing is that if you want to deliver higher data rates, then we've really got to start looking at using 2 RJ45 connections. And that's not just to deal with the data and the data transfer, it's just about the way that that wireless access system is actually going to deliver the data. And what we're seeing is that even though some of the predictions or recommendations on the wireless access boxes might say that they can support in excess of 100 meters in distance, in reality, the standard could only be 70 meters. In fact, it could only be 45 meters in the internal environment. And one of the reasons why it could be reduced about it is about thinking about which one's going to be more important. Is it going to be distance or data throughput? How many of us have been in lots of environments where we take out a device, a laptop or a mobile phone, we see the wireless network, we connect to it, it says that we're connected, but we just don't receive any data. And that's really important because we've got to think about the obstacles that the building fabric. Is wireless signals going to be effective to be able to get through glass and concrete walls, etc.? And what type of interference from one wireless access system to another might actually affect the data throughput. It's really interesting about a major university in the UK. They spent an enormous amount of money on doing a huge wireless access refresh. And it's quite important that I mention this because they each gave themselves a huge pat on the back and they said, we've delivered this super multi-million pound new wireless infrastructure, and then they found out it wasn't highly effective. And one of the reasons why it wasn't highly effective was they didn't consider how many IP-enabled devices students would have connected at any one time. They made the assumption that probably students will probably have 2 devices connected, a mobile phone and potentially a laptop. But they didn't think about watches, they didn't think about IPTVs, they didn't think about all of these other solutions. When the university went back and actually really drilled into it, they found that the average student would have something in the region of about 6 devices connected at any one time. And that really drove a huge requirement for change on a very newly installed network to be able to support the needs of their customers, the students. So, and some of the claims I do struggle with. Some of the higher end and more expensive Wi-Fi solutions say that they can support up to 255 users connected to any one Wi-Fi station. But every connected device will reduce the amount of performance through that network, back to your broadband provider. The more people connected, the more that total bandwidth is being used and consumed. I was thinking about a hotel, and pretty simple. I was thinking of a very small hotel, 18 bedrooms, every room's booked, they've got 2 guests in every room, and I'm only actually going to be very kind here. I'm only going to give them 2 devices each, but there's 72 devices connected to the network. And the reality is we can really only potentially believe that about 50% of people will have a real working connection. And I ask this, how many of us have stayed in hotels and we know that the wireless base station is just a few 4 doors, 5 doors down from where our room is, and we struggle to get connected? So it really made me sort of think about what is the availability, how much bandwidth do we have, and what does it really take to make things work? And I'm just sort of thinking of things that I personally would look at or need when I'm working, on a wireless-based system. I could be using instant chatting, messaging, voice over IP calls. I'm definitely going to be sharing files. I'm definitely going to be having video streaming. I've got video calls. Yeah, I'm on the browser because I'm either web browsing for work or I'm doing my own social media. I've got emails, but not just emails. Then I've got file sharing coming in. And then if you look at the hotels now, most of us use our laptops to connect up to Netflix or Prime or whoever, so we can download our video content. And it's quite difficult sometimes when you've got all the buffering. But this is only talking about 18 bedrooms, 72 users with 2 devices. And the reality is, it doesn't always work. So we've got to put more and more wireless into those environments. Intelligent lighting is really, really starting to come into its own now. There's effectively, I suggest 2 types. There's power over Ethernet, and there's something called power and Ethernet, which is a UK-based manufacturer who delivers power and internet controls directly to the end devices. Many of these things have been around for many years, but it's only really, I think, in the past 4 to 5 years that we've seen this market start to gain some level of market adoption. And if we start looking at it, we're seeing huge growths in this lighting market, from, 30% growth year on year, just in a matter of 4 years. As with all technologies, not all are the same. We urge you to think about drivers and their locations. And this is really, really critical when I come back to building design. Lots of traditional lighting companies that have entered what we call the PoE lighting market, they tend to have their drivers located very, very closely to the light fixtures themselves. Many of these LED drivers will only have a lifespan of around about 2.5 years, whereas the LED lighting systems can actually have a lifespan of 10 to 20 years because they can operate up to 50,000 working hours. So careful design about the technology and where we're going to put the flexibility of the system. One of the ones that I carefully try to consider and try and convey to customers is about removing the drivers from the lighting grid system and moving it more towards the telecommunications space, so we can gain access to drivers and replace them if we need to, without having to disrupt a whole office environment just to go up in one area. Just on the picture here, if I had one LED light go out there because of an LED driver, I'm effectively going to have to ask 6 people to move. I'm going to have to move their desks just so I can get up into that ceiling space to work and replace that LED driver. It's not efficient to have it, to my mind, directly in the lighting grid. But what else do you need the lighting system to be offer beyond lighting? Earlier I mentioned about the integration of lighting and a fire alarm system. We can do things where, as everybody comes back from lunch and and after you've had a good meal and it can be quite hard to engage that. I think they generally call that the graveyard shift. Well, the corporate business might actually design to change the hue of the lights and make them slightly bluer. And that psychology or process will make you feel that you're slightly colder. So you won't go into that graveyard shift. Because you'll feel slightly colder, you'll be more awake. We can put other systems into this, such as Li-Fi, people tracking. There's a whole host of systems that are coming out onto the market, which will go into what I call the intelligent ceiling grid. Li-Fi is really going to be one of the biggest game changers I'm going to see. And this is going to be able to use an LED in a light fitting to transmit data. So the LED lighting systems can switch off so fast that we can't even see it in the human eye. And we can actually use that on-off signal to be able to transmit it as data, zeros or ones, and it will be our data transfer. I've seen lots of discussions about Li-Fi over the years. I've seen lots of solutions come onto the market that are good. Some are extremely cost prohibitive, but there are changes in the market which is going to be driving this forward. One of the great benefits, though, about Li-Fi is incredibly secure. We don't have to worry about radio waves and securing external interfaces that are going to potentially disrupt or infiltrate our network through those radio wave signals. We're just not going to have that environment. So data transfer on the download is huge. I've actually seen some people who are actually delivering 100 gigabits data on a download stream straight through a single light fitting. But that's very early stage. It's very theoretical. Well, when I say theoretical, it's been around for about 5 years. But the real focus is about how do we bring it down to a commercially viable speed. And the real thing about this is about not just downloading, it's also going to be about uploading. So you're going to have a dongle which will plug into, say, for example, whatever your desktop device is, whether it be a laptop or a fixed desk PC, but you'll have a little dongle that will plug in, and that will be able to download and upload files. And typically, some of the files, the data transfers I've seen at the moment are around about 100 megabits per person. And I guarantee that this data rate's only going to increase. With one of the manufacturers that I'm doing a lot of work with, really investigating into Li-Fi, they fully expect a commercial product to be available on the market at around about $250 per desk. Lots of companies are out there just saying, well, if you actually need to have Li-Fi, you're going to have these hugely more expensive light fittings. Well, the answer is you don't. It's just about modulation. How do we turn them on and off? And there's a lot of focus on that. And equally, that when a light shines down, we don't need, as this particular picture may predict or show, a light fitting over every desk. I was recently in a corporate boardroom of 10 desks, and we were all connected to the Li-Fi, and we all had, well, in excess of 100 megabits whilst we were in our meeting. And that was, there were 12 lights in that meeting room, and one of the center ones was one that was developed for delivering Li-Fi. So just before actually I go on and talk about single pair Ethernet and some of that, the technologies that I've already spoken about, the growth of intelligent lighting, the growth of Li-Fi, the growth of Wi-Fi, and all of those other PoE-enabled devices, there's one very common denominator that sits amongst all of those, and it is Category 6A 10 gigabit based networks. It's copper-based networks that are delivering all of this connectivity. We can't deliver power truly and very easily over fiber. Yes, we can buy a power cable and a hybrid cable that contains, power and fiber optics, but then we've got to have a lot of additional electrical costs to be able to separate the power from the data. There's a lot of people now talking about single pair Ethernet. And this is really to support both powering and data, either 100 megabits or 1,000 megabits over a single cable pair. And it's been around for a while, known as Poodle, power over data lines. But in truth, we've got two versions. We've got SPoE, single pair Ethernet, single pair over Ethernet, and Poodle, power over data lines. SPE is typically used in the terms of the classification in what they call operational technology, OT technology. Yeah, whereas Poodle is really going into what we call engineered networks, so like in-car networks. So there's two real sort of divisions, and if you look at them, they work slightly differently. If you think about Poodle, especially in the automotive industry, it's really about fast power detection of end devices prior to power delivery. It's really about much shorter reach distances, and it's really about making sure that as soon as you turn that car on, all of those sensors are going to be working. And especially as we think about the autonomous motor vehicles, we've got to have that high-speed data transfer. Operational technologies, where we start thinking about SPoE, it's really going to be about lower power solutions. We need to be able to measure things like cable resistance and everything else, but power delivery is slightly shorter distances in some terms, depending on the applications that we're going to run. So one might be more for the industrial environment, but the real drive for single pair Ethernet and Poodle really was the automotive industry. So there's the various flavors. There's 10 base T1S, 10 megabits over Ethernet, a single pair balanced twisted cable, 15 meters, but an allowance up to 4 inline connections, so we can daisy chain. T1L, 10 megabits over a much longer distance, up to 1,000 meters, with an allowance of up to 10 line connections. So there is a lot of discussion, a lot of marketing promotion about single pair Ethernet going on into the market. And we can see some of the applications there and the distance that we're actually going to be able to deliver these solutions. So where will SPE be deployed? Well, as I said earlier, the automotive really was the original focus for SPE. And even though there are SPE connectors out there, they're not going to work in the manufacturing environment for a motor car. These manufacturers will likely develop their own type of connector and their own type of chipsets to make these systems work. Industrial applications, well, that makes some sort of sense. Obviously, we're obviously looking at SPE connections, and we are seeing new standardized connectors available on the market. At Siemon, we're really watching this space, and the reason why we're watching this space is, were we a bit forward-thinking back in 1998 when we brought out a Terra connector, which was originally designed for pair sharing, single pair applications. Now, some of the marketing stuff that I'm reading from people who are really promoting the SPE sort of single pair Ethernet solution is they're saying, well, it's going to be much easier, more cost-effective to install, and a little bit more flexible and lower containment costs. Well, I'm not really sure if I agree with that, because when I look at the cost of a single pair Ethernet cable, and then I look at something like an SFTP cable, there's a whole new host of conditions and controls that need to be placed on the 2-pair Ethernet cable. It's quite hard to actually get the signal onto that so it's going to work. And then if you're only running one cable and then you're having to deliver another cable and deliver another cable and deliver another cable to say 3 or 4 devices, is that really offering value? Whereas what you could do potentially, and it's totally up to you, is you could use the Terra connector with our Siemon category 6, 6A or category 7, 7A versions, and we can literally deliver this for pair sharing. And that means that we could deliver a 4-pair cable to a zone enclosure close to where the devices need to be, and then we run a single pair Ethernet cable, which will go from RJ45 to whatever that end device needs. And not all of those end devices will actually probably adopt an SPE connector. Most of those will probably adopt the Green Phoenix style of connector, which is really good in our platform of being able to work with that. Siemon reached out to a fire manufacturer, and we actually have supported 10 base T1 link up to 400 meters, just because that was what I had around at the time to do the test. And we delivered all of those applications without error, and everything worked properly. But even though I talk about all of this, and it does sound really, really exciting, it's this chipsets. They're not readily available on the market. And this market may not even progress for many years to come. It's great that we've got manufacturers out there and technology people that have come up with an idea to support single pair Ethernet, which is a great idea, but we've got to gain market acceptance. But we've got to see some sort of level of a customer going back to a manufacturer and saying, I want SPE. Until that really starts happening, I don't think we're going to see a huge amount of investment into the chipsets. Now, that's saying not that I'm not saying it's not going to happen, but I think we could be 3, 4, 5 years away from today before we really start seeing that come onto the market. But that's like with lots of technologies. Lots of technologies have been out there, and we've just seen very little market acceptance for it. One thing that I quite often get asked is about, well, where is the growth of fibre going to be, especially in terms of the enterprise environment. And people, it feels like every couple of years I see the word passive optical networking re-emerging onto the market. And lots of people saying, oh, look at this new technology. It's not massively new. The whole idea of passive optical networks really came back into the marketplace in the late 1990s, 1998. Today, it was upgraded to what we call 10G-PON or 10 gigabit Ethernet systems. But the reality of this is it's really become popular in perhaps what it was designed for, and that's the carrier side of the network, you know, where the carrier can say, I've got 5 high-rise buildings, you know, office complex in a close proximity. What I will do is I will deliver a dedicated throughput of data to each of those. And then that throughput can be given to one area or location, but in reality, the total available data is really shared amongst all of the subscribers. Over the years, we've seen lots of people pushing for PON-based architectures, but I've never really seen it develop how I would expect it to. And I've got some ideas. Well, number one, if you're going to go into an commercial enterprise environment where we're thinking about high bandwidth, well, we've got shared maximum bandwidth. So if you've got, say, I don't know, 20 users and they've got 10 gigabit coming in, you know, they've got 500 megabits of data. Increased amounts of fiber distribution. Typically, we're going to see one fiber pair from every ONT to every connection device. But the reality is that to be able to convert to a wireless or a desktop or any other electrical signal, we've actually got to increase the amount of electrical connectivity back towards the junction point or the ONT, because we've got to put converters in, costly, which are going to convert the optical signal and then transfer it back into a digital signal. And I think that will create some latency on the network, but it's also going to not really make the building future-proofed, because the reality is none of this will be able to support really true power over Ethernet applications. So there's lots of discussions about the future of copper versus fiber in the industry. One thing I will say is there is a massive, over the last 5 to 7 years, there's been a massive increase in terms of the fiber systems that are being deployed into the data center. And we're going to see that continue. Data centers, you know, they're running at 10 gig networks, 40 gig networks, 100 gig networks. And we're now seeing some of the very large data centers actually requiring, you know, data links up to 400 gigabits. But they typically long haul, you know, point-to-point connections. You might see lower data rates, you know, in single row connections. But fiber's really growing in that data center environment. There's evidence and positive need for fiber growth in the external-based networks, yeah. And we're really going to see that pushing forward. There's nothing we can do. You know, we need more enhanced data throughput at home. I know that I definitely do. I have a pretty good data throughput to my home office. But, you know, there's other people in my house. There's children, there's family that come and visit. And every time when they come and visit, the first thing that they do is they go, what's your wireless network key? And they connect to my network, and they reduce the amount of throughput and data that I'm paying for or have made available to myself. So copper-based connectivity is still growing, and it's still being supported by, you know, the growth of PoE-enabled devices. You know, this is really helping to reduce power and really helping to increase the users and the building owners' experience of how they use and how they work in that environment. It's providing flexibility to deliver whatever any RJ45 IP-based system is. And it's about building the roadway. Whatever we're going to throw at this road, the reality is most of our 99.999% of applications in the future will still run on data rates from kilobits up towards 10 gigabits and probably not far beyond. So copper and building that roadway is a real important part for us. So ladies and gentlemen, I'd just like to thank you for your time today. Some of these thoughts were mine. You might have different thoughts, or you might absolutely agree with what I'm saying, which would be lovely. But what I'm going to do is pass this back to Chris now and open the floor to any questions that any of you guys may have for me.
Thank you very much, Lee. As Lee did mention, if anyone's got any questions, please enter them into the panel right now. We did actually have a few questions come through while you were talking, Lee. The first one here, so you were alluding to fiber. Essentially, someone's saying, when will fiber take over?
That's a really good question, Chris. Many years ago, I was a director of the Fibre Optics Industry Association based here in the UK. And I was a director there for, I think, 15, 17 years. And one of the most common questions that we would always get asked is, when will fibre take over? And even as the Fibre Optics Industry Association that was writing, developing standards, thinking about where the future of fibre was going to be, we always had to say it won't take over. It's going to be a long time before we start to think about that. In some of the fibre-based networks out in the carrier networks, that's going to happen relatively in the next 10 years, because people are going to go away from traditional copper-based telephony systems with switching. They are going to move much more towards IP-enabled networking. And that will roll out to our phones at our home addresses, because most of us are using, smartphones now, as opposed to, the standard own POTS or plain old telephones. But the inherent issue is, if we think about the enterprise environment and trying to reduce power, we need copper. And the copper is going to give us the power that we need to drive those devices. It's going to be able to switch and control the amount of power that a device needs. What's really interesting is, I suppose, a bit of a difference between copper and fibre. Fibre switches, they run at 100% full power, 24/7. That's it. They're just on all the time, just delivering data. If I think about a copper-based network, we have things like energy efficient networking, where my copper-based switch going to my end device might actually say, well, how far are you away from me? Oh, you're sub 30 meters, I'm going to use less power. And that's been a real driver in the data center market for how we design some of the cabinets to enhance better power reduction by reducing the length of cables, copper cables between switches and servers, etc. So we're still going to see copper based there, and it's still going to drive us forward. But if we are really committed to power reduction, power over Ethernet is the way to go, and we need copper for that.
Very well put. We actually just had another question come through. Someone talking about Cat 8. So they're saying, what about Category 8 copper solutions? It seems to have disappeared from the market. Do we have any idea of what the market share is up to date and what the adoption's looking like there? That's great question.
Yeah, I wish I had my crystal ball. So Siemon, we I don't want to blow our own trumpet. We took our Terra connector. There's two types of Category 8. There's 8.1 and 8.2, one on an RJ45 and one on the Terra connector. We took that connector that we developed back in 1998, put it back through testing, and it's superseded the requirements that are required for 40 gigabit Ethernet. So 40 gigabit Ethernet is really aimed at the data center environment. It's 40 gig based networks. It's very short reach, 30 meters. And is it one of those technologies that everybody wanted to promote, as I said earlier, but nobody really wanted? And that's a big question. Is it something somebody really wants? Or is it something somebody, is it something that a standards committee really want to try and promote, a manufacturer might want to try and promote? Is it something that a switch manufacturer really wants to deliver, or is it something that an end user might want? Well, if we start thinking about it, and it's quite strange, because if we look at that data center environment, what are we really seeing a growth in? We're seeing a high growth in enhanced data throughput on fiber for long haul and enhanced distances with greater data needs. But we're also seeing that growth for DAC cables, AOC cables, which are much shorter distances. But we're seeing a massive growth there for point-to-point connection using those solutions. So I do think there's always going to be a place, you know, for 10 gigabit in our networks from, you know, patching and connection. But the real sort of higher data rate stuff, I think, is probably going to go down the DAC route, the AOCs, and fiber-based routes. I think in the last 2-3 years, I've probably looked at 3 designs for 40 gig, and I think we have delivered 1, and that's a reality from our region.
Okay, thanks for that, Lee. And thank you very much for that question. If anyone else does have any additional ones, please feel free to keep sending them through. We did have a couple of others, as I mentioned earlier. So you were talking about the growth of intelligent buildings at the beginning of your presentation, Lee, and this person was saying intelligent buildings, we actually get asked this question a lot. Intelligent buildings, they're saying, why is the adoption so slow?
I think the adoption's slow from 3 areas. Area 1, consultancy-based design. Consultants are changing now, and they are starting to look at more of this technology. But excuse me. But many consultants have been designing and adopting a design costing process that they've used for many years, based on, you know, a cost per square meter, and then they're very much used to working with the electrical, the M&E contractors, and the M&E contractors equally are looking at that intelligent building, the use of power over Ethernet, and trying to find ways to block it. You know, if I was an electrical contractor and I'm now being told that I've lost 30,000 light fittings in a building because they're going into power over Ethernet and they're going to LED-based solutions, I'm going to be very concerned. If I'm starting to see that I've got to actually deliver less power sockets to an office environment because we're going to be using that RJ45, I think that's going to be a concern. And I think probably one of the biggest ones is fear. People do seem to think about this as being somewhat like new technology. Well, the reality, that isn't true. We've all been working in our offices, running on copper-based connectivity, driving our computers, our laptops, you know, our phones for many years. And you know, I know people talk about the level of utilities that, you know, in a building, that you're going to need water, you're going to need light, you're going to need data connectivity. Well, if any one of those 3 things were lost, you're out of business, you know, until they're resolved. You know, gone are the days where we're writing things by hand. And if we think about that, most of us, when we're sitting there with our networks and everything else, we've used our computer systems error-free for 30-40 years. So it's not new technology, it's just a different type of technology. And I think people need to really, from an end user point of view, really need to say, I want to think differently. I'm going to push my consultant to do something different, because this is where we're going to get those energy savings and cost savings.
Okay, that makes a lot of sense. Just had another question come through. Someone asking, what about safety? Do you have to be an electrician to install power over Ethernet solutions?
That's a really good question. There was a discussion, I know, in the US a few years ago where the electrical installers in North America were really trying to say, well, this is electrical, we should be installing it. We saw a similar thing across Europe, where the electrical industry associations were trying to do some form of self-protection. But we've got to think about how power over Ethernet works. Well, it will only deliver power to an end device that requires it. That's it. And it's all low voltage. It's not at a voltage level where it's actually going to do any real physical damage to any person. So it's intrinsically safe. And no, it's going to be installed by your data engineer.
Okay, excellent. And related to the question earlier around IB, we've had someone else follow up around the copper side of this, and they've said, is copper the best option for intelligent building environments?
Well, I'm going to say yes, because you remember all the devices that we're going to connect up do need power, and that's going to be delivered via copper over power over Ethernet. We need the data transfer, that's going to be delivered on the same cable that's delivering that power over Ethernet. And if we start looking at other systems such as wireless, well, number one, wireless needs data and it needs power, and that's delivered by PoE. And other sort of technologies that exist, they all need power, and they are seeing massive reductions in the amount of power that they need, and they need increasing amounts of data bandwidth. And that's why, I'm strongly promoting, a roadway based on, 10 gigabit Ethernet, because that will deliver the best possible solution to a building. But if the person asking that question has other ideas, I'm always open to be educated and to look at them. So if you can let me know who that is, Chris, and we can perhaps follow up with that, and then let the group know where we are with that discussion.
Yeah, of course. Another question that's just come through talking about, they're asking, what about fiber to the room? So they're mentioning, and you sort of used this phrase earlier, they were saying, so is it only, is only the last mile copper with power over Ethernet, or can fiber be in there as well?
Well, you can deliver a hybrid cable where you can deliver copper, electrical, and you can deliver fiber within the same composite cable. One of the big issues that I haven't massively looked into it is the CPR requirements for a hybrid cable. I'm sure they're out there in terms of their fire resistance. But the reality is, I've got to take that fiber, and we are going back to that pond discussion. I've got to take that fiber to that room or that location. I've then got to connect that into a switch or a device that's going to convert the optical signal into a digital signal, and then I'm going to patch that out through traditional structured cable into those end devices. In some ways we do deliver fiber to the floor, but we deliver it, through that switch-based networks and those switch-based networks, and that's the way that we've been doing it for many years. But we're not really, focused on fiber to the desk, if that makes sense.
Okay, excellent. I think we've just got time for one more question. And thank you all so much for sending these questions through. It's brilliant. We actually had a question in here, Lee. You alluded to SPE, single pair Ethernet, earlier on. And there was a question here around the fact that we've heard an awful lot about SPE. There's been a lot of column inches written about it. And you alluded to some of this earlier, but they were just asking, what do you think are we looking at with the adoption timetable for that technology? Do you think it's imminent, or is it something that could take a while?
I think it's going to take quite a while, Chris. I think the cables need to go through a lot more validation to get their pricing to the right level, the right fire requirements. They're going to be very specialized cables. There's no two ways about it. They're going to be a very specialized cable. It's not going to be just like a standard, data cable, because SPE and the amount of data that it's trying to deliver is going to be highly susceptible to external noise. And if we think about that going into, so for example, an industrial environment, well, by definition, there's going to be huge amounts of noise. So there's a lot of work, I think, that's got to be done on that. The automotive industry, yeah, they're going to go their own way, and they were the market driver, the original market driver for SP, single pair Ethernet. But they're going to go off and do what they need to do at their level. In terms of the industrial and the enterprise, and the enterprise really only came along as like the third thought or discussion. But I think we've got to wait for switch manufacturers to really have commercially available devices that are going to be able to drive it. We've got to have the cable, we've got to have the better connectivity. I think the connectivity could probably be, we're doing a little bit more robust than what I've seen on the market today. And with all that said, I think if this market is going to grow, I don't expect to see much growth within the next 4 to 5 years. So, I fully expect a window of around 5 years before there starts to be market acceptance towards SPE.
Okay, brilliant. Thank you very much, Lee. And a huge thank you to everyone again for your questions. Really, really appreciate you joining us and for engaging. And we are at time, so I'd just like to say a huge thank you to all of you, as Lee mentioned at the beginning, for taking time out of your days to join us, and also to Lee for his time and insights today on our session. We hope you all enjoyed today's presentation and look forward to seeing you at one of our other upcoming Tech Talks throughout 2022. And as always, if anyone's got any additional questions or would like any further information on how Siemon can support you with your copper infrastructure requirements or fiber in the data center or in the intelligent building environments, please reach out to your local Siemon representative. Thank you very much and have a great afternoon and evening wherever you are in the world. And thank you very much again.
Thanks, Chris. Thanks, everyone. Bye-bye.